Hello class. So in this video, we talk about machine intelligence. So, when you first look at this name, so you feel machine intelligence. So it seems to be the combination of machine learning and artificial intelligence. So for those of you who have known about these terms, so the answer is yes or no. So under the context of IoT, machine intelligence is actually more than machine learning and artificial intelligence. So let's see what's happening here. So as we mentioned earlier, the foundation for any IoT solution is the IoT device. So it's clear. So the sensors can provide data and the actuators will consume the commands and do something, right? So the means to put the IoT data and control commands to meaningful work in IoT solutions is machine intelligence. Basically, with only data, we need something to process data so they can put into something meaningful. So, and that means is machine intelligence. Data on itself has limited value. My PhD advisor told me about this many times. But data is raw material to be used to extract richer information and insights altogether, so it can be visualized and exposed for human understanding. For example, when you have a lot of data, you may use, in the simplest example, you will use Excel to process it. You may draw some charts. You may put some bars to indicate for example, the trends or the distribution. So those actually is kind of extracting the insights. But of course, machine intelligence can do much more than that. And we may also turn it into actions that automate process and control of an asset under the context of Internet of Things, right? So for machine intelligence, well, in this class, we define it as a set of capabilities that turn data into information, knowledge, and actionable insights. So it is also capable of reasoning and making recommendations and decisions, as well as taking actions. So it is hence capable of controlling the physical environment. So let's just use a figure to show this process. So we have sensors to provide, let me change color of a pen. Sensors to provide data, right? So with some lower level processing, we can catch the knowledge there and provide insights. For example, if you plot the data and then you can see how the data is fluctuating, whether it is increasing or decreasing. For example, you look at the stock price in the past 2 years. And based on this knowledge, if we can do some reasoning and make decisions, we can provide some suggestions, conclusions, recommendations to people. For example, by processing the data of your browser web browser activities, events, then it will be able to recommend similar videos to you on YouTube, right? And after reasoning, most of the time we may also need to act to the environment. So that involves execution and automation that will be implemented on the actuators and bring benefits to people. So this figure shows the basic interaction between the physical world as well as the machine intelligence element. And just like before, when we choose to use vans or lamps, basically we depend on the specific situation of the problem, right? And the same also here, depending on the IoT application, different machine intelligence technologies need to be considered. So we have 4 examples here. For example, we have the massive monitoring. So just like monitoring the climate environment, just pay attention to the key point here. So for this application, the key MI features are anomaly detection. Basically, we should be able to tell whether it's something abnormal is happening, and clustering of data and predictive analytics. Basically, we need to predict what will happen. For example, if we monitor the weather have been changing in this way in the last 2 months, so we may be able to predict whether it will be a warm winter or a cold winter. Another example is asset management, just like building automation. So we look into the heating, ventilator, AC, water boiler, those kind of things. For education, key MI features include simple trigger and abnormality detection, but basically I think this is needed everywhere. Programmatic control, basically we'll be able to act back to the environment. For example, if the temperature is too high, then we just lower it up, right? And tune regulators, multimodal cleansing, and using some algorithms. So that's a requirement of machine intelligence for this situation. For logistics, there are a large amount of actors. Actors basically means people involved in this process. So it includes suppliers, distributors, consumers, right? So for the MI, it can be used for cost optimization. They can be used to check the goods. They can be used to keep the product stock levels low. Basically, we don't need much required here. We need much inventory to reduce the cost. And also, we can do some optimization with conflicting objectives. And MI can also do complex planning. So basically, MI can play an important role for logistics. Basically, every aspect needs MI. For robots, the MI should be able to ensure proper and safe behavior and identifying the context in real time. Basically, for the machine intelligence algorithms, if we are using them, they need to be implemented in real time. So it's not like we input the sensor data and then wait for 2 seconds to see what comes out. So 2 seconds many times can cause accidents. So in this application of robots, the MI need to be real time as an aspect. So for the machine intelligence, as we mentioned, we need data, right? So data and information can be produced and consumed within an organization. For example, we can be within an organization like NCNT, right? And also it can leverage from the external sources to augment the application. So if we want to, we may also collect data from other UNC system universities. And for within an organization, it can come from the sensors and also can come from documents and other resources. IoT applications involve multiple stakeholders and actors. So an IoT information become a shared and sometimes traceable asset. We mentioned this earlier in chapter 3, I think, for the business aspect of IoT, right? Nowadays, so the data can be sold, can be exchanged, and the information product can also be sold and exchanged. Okay, now let's come to the definition of machine intelligence in this course. It is the combination of methods, tools, and techniques from machine learning and artificial intelligence. Okay, finally, you see these two words, right? The purpose is to create data-driven, intelligent, and non-fragile systems for automation of tasks and processes to enhance human capabilities. Okay, machine learning, artificial intelligence, and for IoT, because it involves physical assets, physical actuators, so we also need to incorporate control theory to our definition of MI. So as its name indicates, control theory talks about how to control the device, control the actuators, control the machines. So if we use a figure to illustrate the different aspects of the machine intelligence, so we will see that we have many techniques combined together. So many of them you may have heard of, for example, the reinforced learning, deep learning, rule-based control, predictive control. This is more related to control. And for the game theory, definitely it is game theory. Okay. And supervised learning, machine statistics, optimization. Well, basically, IoT is a multidisciplinary technique. So for those of you are not familiar with machine learning and artificial intelligence, so we have a brief description here. So it is for machine learning, it is a discipline in computer science, aiming at giving computer the ability to learn without explicitly programming. So for example, in the healthcare situation, so for some disease, we have some syndromes, right? So for machine learning, one application is to input the symptoms of a patient. For example, whether the temperature, so what's the temperature, whether the patient has headache, whether he has any other symptoms, and then the machine learning algorithm will give you not an answer. I think it's a suggestion that, okay, it is most likely that the patient is having a cold or having a fever or having a COVID-19, something like that. Okay, for artificial intelligence, it's about software and algorithms that intend to model and behave as humans behave and think. Basically, it mimics how the human brain solves problems and execute tasks. So sometimes most of the time we can think that there are some overlaps for these two families. So for AI, most of the time we will also use neural network, right? But we're not going into details on that. So as we saw above, so MI is used in numerous different disciplines, commercial deployments ranging from financial systems, healthcare, medical science. So we have some examples here. The ambition in IoT, the ambition is to have a system that behaves like a physical world, according to the laws of physics, and to make things behave naturally. For machine learning, it's based on different algorithms that learn from data and build models from the data that can be used to make prediction or decisions. So you may have heard of decision tree, heard of support vector machine. You may heard of random forest. Basically, those are machine learning techniques. So basically, machine learning is a big family of techniques. Okay, so we have supervised learning, unsupervised learning, and reinforcement learning. So for this course, just get to know these terms. But if we are really interested in this, so we have courses in other departments focusing on these techniques. So those courses are quite fun, in my opinion. We will learn a lot of different techniques, and then you will be able to use these techniques to solve some real-life problems. So AI, on the other hand, has a focus on providing abilities like knowledge, interferencing, reasoning, and planning. And control theory is about continuing operation of a dynamical system. For example, for a machine, for a robot, so it's a dynamic system, right? It involves a lot of sensors, a lot of motors, I think, and also some valves, pneumatic components. So it needs to be monitored and operated continuously in a stable state, in a stable level. Okay, for the machine learning, for the machine intelligence, so we have some typical examples or tasks. So for example, descriptive analytics, so it provides insight into the past. For example, we look at the trends in the last 2 years. We look at the average. We look at the something like that, right? Descriptive means what happened in currently and in the past. And also we have predictive analytics. Basically, we will predict what happened next. For example, we will monitor the temperature in the past 20 years. So can we predict what the temperature will be like for the coming year? So that is predictive analytics. Clustering, basically identify all groups with similar characteristics. So for example, nowadays in the agriculture applications, so they are using computer vision to identify the defective and the good fruits. For example, apples. Basically, they take a picture of a group of apples. Then by using the clustering algorithms, they can separate the apples into different levels, kind of, because you know that if an apple is big and red, it can be sold at a higher price, right? If it is just normal size, normal color, so it's okay. But if it has some defects, it needs to be disposed, or it may only be sold at a lower price. Previously, people are employed to do this. Basically, they pick up an apple, evaluate him or herself and then put it into the corresponding basket. But now this will be done by the computer using clustering methods. And also machine intelligence can be used to anomaly detection. Well, as I said, behavior data identify outliers that represent an abnormal situation, and also action programming. So for each task here, so I include a short description to help you understand. To be honest, I think the name themselves are quite straightforward. And task planning, knowledge representation, modeling representing the physical state and behavior of an asset. So this comes up with a fancy term, digital twin. So twin, you know what it is, right? But it's a digital twin. That means it's a digital counterpart of the physical machine, physical product. So actually that's my research area. Okay, how IoT data needs to be captured, processed, stored, managed, and consumed varies depend on the type of IoT applications ahead. So mention similar sentences several times in this course. Basically, the techniques we used, no matter for the sensors, actuators, the networks, and also the machine intelligence, they all depend on the specific application, okay? So if you really work into this area in the future, so a basic requirement is that you are familiar with the options you have in each stage, right? For example, if you need to choose a network, so you should be able to know Bluetooth, Wi-Fi is the minimum, but as we mentioned in the previous video, there are many other new options. Those are things you need to know. So for the IoT situations, we have sensors and that collect data day and night. So we come to the situation of the so-called big data. So yeah, this is also a fancy term in the last few years, but nowadays is how people have been seeing through what's happening after big data. So basically it is big data, the term itself is not as popular, but the techniques to deal with big data, for example, machine learning, artificial intelligence, they are getting more popular. Okay, for big data, why we call them big data? So there are several V's. First of all, volume. So the volume needs to be big, right? So it will be gigabyte, even higher. And also, the second V is velocity. Basically, velocity is about analyzing streaming data, for instance, real-time operation data from the farm of wind turbines. Basically, what it means is that not only we have a large amount of data, but the data are coming very fast. Basically, for each second, you have 0 gigabyte data. That means those data need to be processed timely, right? Variety, which is easy to understand for the data, it can be text, it can be video, it can be image, it can be other things. And veracity, it is basically it means about that the data need to be reliable. Basically, they need to be validated, and also the data need to know that the provenance of the data need to be known. Provenance means that where the data are created and under what context, right? Especially when you're using data from other companies, those information are needed. Under the context of IoT, we also have the volatility. Okay, the next way, basically, it means that IoT data itself can be non-persistent. What it means is that, so we mentioned that the sensors may be producing a large amount of data, right? And for some applications, we may store the data, right? For future use, maybe. And for some other situations, we just process the data, maybe in real time, and then the data will be gone. Basically, we don't spend the resources to store the data. That means that if after processing, the data is gone, in that case, it may not be able to check back, okay, come back to see what happened in the data. And also, data relevance can also be degrading over time, thus removing the need for storing the data. So that's another aspect. Basically, what it means by volatility is that the data need to be made good use of at the first time. So in many situations, it's not possible to come back to process the data for another time to see whether it was processed correctly before. With the 5 V's of big data, it is important to understand and have a strategy for where the data is being processed. What is that? Does one bring data to the processing or the processing to the data? If we bring data to process it, that means that the sensors may upload the raw data, basically large amount of raw data for example, to the gateway device and also to the cloud, maybe a remote data center far away. Let's bring data to processing. Or if possible, we may bring the processing to the data. For example, for some basic device. So although it is basic, it may still have some processing capabilities. So one solution is that we develop an algorithm that we can process the data just on the device itself, especially if it is quite an advanced device, right? For example, if you are using your iPad, so obviously we are bringing the processing to the data, right? To properly answer this question, we need to have a combined consideration of volume, velocity, the 5 V's. So actually this comes up with the idea of edge, fog, and cloud computing, which we will cover in the next topic in this unit. But during this process, just keep an eye on the user privacy. Okay, so in the chapter 3 or 4 unit, in the chapter 3 or 4, we talk about the reference architecture for the IoT unit. So for the machine intelligence of IoT, we also have a reference framework. So by saying reference, it means it is a general version. It tries to provide all the options. So the presented framework should not be. So basically, it is what we are going to present is a conceptual or functional reference framework as shown here. Basically, it identifies the key elements and the functions of machine intelligence framework for IoT applications. So just keep an eye here, a framework for MI. So it is related to the machine intelligence. It is not a framework of IoT applications, okay? So as we see some elements here, so we wrote these elements into a little bit more detail. The MI framework provides the previous discussed functionality is to realize the variety of use case capabilities. An objective of the framework is to partition functionally into application-independent building blocks that can be implemented as service-oriented software components. So what it means is that, so we see this framework, we see many circles, right? Basically, each circle is a functionality. And the idea for this framework is that each function or each block, each circle here, can be developed as a software package. Software. So the benefit is that these functions are clearly separated so that the maintenance and the development process will be simpler because you don't want several things mingled, mixed, twisted together, right? So and also for each circle here, for example, the planner, by its name, you can feel that it can be a software, right? Or at least a functional module. And for the objective optimizer, it sounds like another software component. So that's the benefit of using such a framework. Okay, now let's look at the functional domains more in detail. So we need to have data and resource processing function. So basically, you need to process the sensor data, attenuated service, and their representations. And we have the insight generation. We have the knowledge and cognitive automation. Yeah, basically, for these slides, they are helping you to get an idea of what needs to be included in the framework. So I will leave this reading to you. So we need controllers, we need task planning. I forgot to put this into red color, but it's another component. Objective optimizer, work and objective analysis, object management. Okay, that's the elements of the framework of MI in IoT. In the industry aspect, we also have something called Industrial Internet of Things Analytic Framework, or we can say it is IIRA, Industrial Intelligent Reference Architecture. So let's look at it. So it provides assistance how to develop and deploy analytics solutions in an industrial IoT context and provide guidance into business, something like that. So the difference is that this is the framework for the machine intelligence itself, and what we are doing here is to how to deploy the solutions. Looks like this way. So we have several elements. So first of all, we have the physical assets at the bottom, right? And then we have the control of them. And then operations, informations, and applications need to be provided. And then the top of all things are the business. So in the work by IIC, analytics is mapped onto IoT consisting of the following main functional domains. So the control, information, application, business, and operations, they correspond to the 1, 2, 3, 4, 5 blocks in this architecture. And also from the architecture, we can see that applying industrial analytics is considered in 3 main time horizons. So for the control domain, which is the bottom, it needs to provide real-time operation insights, right? It is the machine time horizon. Basically, it needs to be almost real-time. For example, if your robot is out of control, or it is not moving as predefined path, so we need to identify immediately. And also and for the second time horizon, the operation time horizon, it is related to the machine fault detection and diagnostics. So, well, as its name indicates, it tells you whether the machine or the operation is working properly. So it has some time span in seconds or more. And for the planning time horizon, so it's related to the production planning, so it can happen in days or more, so the 3 time horizons. So it provides a high overview of industrial analytics design considerations, deployment models, and different types of analytics. And that's the conclusion for this section. Basically, that means that we need to use a good combination of ML, AI, and control theory to achieve the true benefits of any IoT solution. And we need to have right considerations and for the particular applications.